Greetings, mathematicians. Here we have the steps to solve an absolute value inequality. So we have less than and we have greater than. So in this case, we're going to look at what happens if we have a less than case. So if we have less than or equal to, the absolute value of ax plus b is less than c, we're going to turn it into an and statement. So the easiest way that I think of doing these problems is thinking of the most basic case that you can, figuring out what logically is going on there, and then from there you can go ahead and turn it into the correct compound inequality. So the simplest case that I can think of is this one right here. So we have the absolute value of x is less than 10. Let's think about what does that mean. So absolute value again is the distance from 0. So we're thinking about what numbers are less than 10 units away from 0. Okay? So let's go ahead and use a number line to help us out. So we have 0 in the middle. Okay? I'm going to put positive 10 up here, and I'm going to put negative 10 down here. So again, we are looking for what numbers are less than 10 units away from 0, right? So any of these numbers in here, that's all less than 10 units away from 0, right? And then same thing here, right? Any number within this region right here is also going to be less than 10 units away, right? So since that's the case, that looks a lot like an and statement, right? Because we have, technically we have an open circle here. Well, let me just go ahead and erase this. We have an open circle here. We have an open circle here. And we're interested in all the pieces and all the numbers in between there, right? So this is technically an and statement, right? So we have that negative 10 is less than x is less than 10, right? That is our and statement, right? So let's take that principle and apply it to more complicated examples. Okay, so we have example 4. Solve and graph the absolute value inequality. So we have the absolute value of 2x plus 7 is less than 11, right? It's an absolute value inequality. It's that less than, right? So that's going to be that and statement. So less than. That is going to be an and, right? So we have and. Okay. So let's go ahead and write it out. So we have, take this number, this 11. So we have negative 11 is less than 2x plus 7 is less than positive 11. Okay? So that is our and statement. Now we just have to go ahead and isolate the x in the middle. So we subtract 7 everywhere, left, center, and right. Those cancel. Negative 18 is less than 2x is less than 4. Go ahead and divide by 2. So we have negative 9 is less than x is less than 2, right? I'm always going through that self-check. It's from least to greatest. It's less than less than. That looks good to me. So that is our answer. It also says that we need to graph, so let's go ahead and make a quick number line. Put your two numbers, so we have negative 9 and 2. Okay. And it's that and statement. The inequalities look good to me, so we're going to have shading in the middle. Right, so open circle, shading in the middle. That is our graph. Okay. Example 5, go ahead and solve this inequality. So we have 2 times the absolute value of 3x minus 1 is less than or equal to 16. Okay. So we need to go ahead and isolate that absolute value. We cannot take this 2 and distribute it through. Absolute values do not work that way, right? So what we need to do is we need to actually isolate this using our inverse operations. So I'm going to go ahead and divide everything by 2. So those 2's cancel out. So we have the absolute value of 3x minus 1 is less than or equal to 8. Okay? Now that it's isolated, I see that we have the absolute value. It is, again, a less than. That implies that we have that and statement. Okay. So let's write it out. So we take that 8, we make it negative, less than or equal to 3x minus 1 less than or equal to h. That is our AND statement. Okay. Now we just have to go ahead and solve. Left, center, and right cancel. So here we have -7 less than or equal to 3x less than or equal to 9. And then divide. So we have -7/3 less than or equal to x less than or equal to 3. And again, let's go ahead and graph that. Our numbers are going from least to greatest. We have less than, that looks good. So we have less than equal to, so that's going to be a closed circle. Also a closed circle. And we're shading in the middle.